Hello everyone, this is another special edition video because for the first time I combine one of my passions, music, with another one of my passions, STEM. And what you see here is a functional synthesizer built from Arduino parts. It does not look amazing on the outside, but it works, and that's the important thing. Now, before I give this a test run, we are going to go over the parts index. Naturally, there is an Arduino which you see here on the right. It's a generic Arduino Uno computer. It runs on the Arduino code, which is just basically modified C++ for anyone who doesn't know. I also provide the source code, which I will go over a bit later. File download is in the description, as well as hardware schematics. There is also an LCD screen with an I2C adapter, which you can see here. It converts a 16-bit pin signal into a 4-pin signal. These things are normally supposed to be soldered right into the breadboard, which are these things. But this adapter converts this 16-bit signal into a 4-bit signal, which is really useful, especially if you have a limited number of pins like you have in the Arduino Uno. Otherwise, the LCD will just eat up vast majority of your pins. Also, the LCD, having so many pins, also draws a ton of power, which I experienced the hard way. Relative to the Arduino parts, which basically need a trickle current, this thing eats a lot. Like, for example, a 5-volt adapter is enough to power this whole machine, except for the LCD, which will either show gibberish or faint, barely visible text. Or if you're unlucky, it just won't work, it'll stay dim like you see here. The LCD needs a 9-volt adapter. Any more and it'll fry, any less and it won't work. It's very delicate. The rest of the parts are pretty standard. You see buttons over here which are pretty weak, they're basic, but they do their job. These are like buttons. These are breadboards, which are basically like PCB circuit boards but on training wheels. You see these arcade buttons, these are the settings, like changing the octave as well as the demo mode. This tiny little blue dial here, that's for volume control. And this right over here is our speaker. This is also a speaker, but it no longer works, so I just did an improvisation and added a better speaker. And there we go. Without any further ado, let's begin. We start by plugging in our Arduino. You can see the message, powered by Reality, which is the tech company I want to create one day. And there was our jingle. Okay? And now we can play it. Just a few words. Just a few words. Thing is, uncivilized mess of wires can cause the B the B note to play frequently. As you can see, this note is pretty jammed, but usually it doesn't have any problems. Just a few words though. Firstly, like Arthur Weasley's car, this synthesizer is much bigger on the inside than it looks. There are only 7 keys, but there are 42 playable notes, which means we have to change it using octave shifting buttons, which you can see over here. The blue one, it increases the pitch further. The red one decreases the pitch. Yep. And the green button is a demo mode, which means it'll show you a song that can be played. And I'll go over that a bit later. But I could have, with the octave shift buttons, I could have increased the range to like 88 keys or like 99 keys or whatever, even like 1,000 keys. But the piezo speakers are not that great quality. They're not Sony. It's like almost pixelated sound, as you heard. So if you go too high, it'll burst your eardrums. If you go too low, and it won't be audible. As we mentioned, the volume can be controlled by the blue dial. Resolution is not that great. You have about like 3 settings. You have like average volume, slightly less loud volume, and then like really quiet volume, and then nothing. So yeah, the piezo speakers don't have that great resolution. And if you pass a certain octave limit, because as I mentioned, I limited the octaves to like C1 on the bottom to B6 at the top. So if you pass a certain octave limit, so let's say you pass the red button like you just did here, it'll show you a message. You won't be able to do anything during this message. It'll just tell you like, okay, go in the opposite direction. You can't keep going past this, so it sticks at that octave limit. It just sticks there. You have to press another button. Whoops, I pressed the wrong one. Yeah. So the same would happen if you press the blue button. It would just say maximum octave passed. Press red to go down. Now let's press the blue button to get out. And if you notice, there are little LEDs next to each button. So if you press the button and you're in the normal range, it'll flash for a bit. And if you're in the maximum range, it'll just stay that color and until you exit and go to the normal mode. And also we have a demo mode, as you can see. I'm going to turn it on. It has a little music note icon. You can't really see it, but there we go. The LED is pretty faint. It tells you what to play to and what notes there were. And a thing to note is that the keys won't be responsive during startup, octave exceeded mode, or the demo. You can exit the demo by pressing the green button once again. Yeah. Well, even though there are a few things lacking in this device, like the inability to play more than one key. Like I'm playing this key, and I'm playing two keys, and it's playing the first key that I pressed. I'm playing like 3 keys right now. I am playing 3 keys. It's only playing one note. Although you can press and hold a note, you can change the duration of the note, you cannot play more than one key. And there's a little bit of lag. See, I can't really like press super fast. I can't like play super fast like I would in a normal piano or synthesizer. There's like a few, like, say about 100 milliseconds or 200 milliseconds of lag. I haven't measured it and I don't need to. Just say there is lag. The volume resolution is low, as I mentioned. And of course there are no sharp keys or flat keys or semitones, because the Arduino Uno has very limited pins. Not enough pins for this LED, let alone sharp keys and flat keys, which would need another 5 pins. So I've basically maxed out over here, so I would need another Arduino Uno connected to a master-slave system, which is basically just attaching another computer into this as another component. It's a bit of a complicated... Even though there are so many limitations, I can actually play a reasonable number of songs, like, for example, Tetris. Or perhaps this song. And yes, that was a horrible attempt to rickroll you with a pixelated device piano. Anyways, if I were to update the device, I would upgrade the demo mode with a range of songs. Like, you'd have a little dial that allows you to change the song. You would have a song record and playback feature. And of course you'd have semitone keys too, but I'd need a more powerful Arduino, or to connect 2 Arduinos back to back. Yep, and this is pretty much the end of this video. There's this final section, the code analysis. And so feel free to skip it. It's just a basic code analysis. I'll keep it short at most. There are few main functions. One is for initializing the parts, one is for startup, and of course the loop function. And then the demo mode function. The last main function is the octave settings function, which is basically a constant loop which decides and evaluates which octave and which note is playing. Since the Arduino is too primitive to recognize note values like A, B, C, D, all the way up to G, we've used the most basic unit of sound, which is the hertz. Frequency. That's hertz right there. Hertz is a measure of how many cycles, or in this case, vibrations per second. In a piezo speaker, which uses a piezoelectric crystal, it means how fast this crystal in the speaker can vibrate when electric current is added. Basically, since this computer only uses hertz, and we have 7 keys here, we have to convert which frequency value corresponds to which note. And of course, the octave changing makes things a lot more complicated since we have a range of 42 notes. And we have to keep track of which octave is each key in. Remember, we don't have like separate keys, so each key doubles or triples becomes several different notes. So that was a pretty hard function to write, and it's an exponential relation that one of my friends in the computer engineering course where I built this exponential relation really made things helpful, and basically converts hertz into an alt value mathematically. And of course, you gotta have a domain, like restrict the domain, but I did that. That was pretty easy. But generally, this function was still pretty hard to write, even with that equation. Oh, and then there was the scroll message function, which basically is a scrolling message. It scrolls all the way to the left. You also see this in the the startup message. That's a pretty good function, I would say. And yes, that's the end of this video. All resources, codes, schematics, and TinkerCAD link can be found in the description. If you want to check out more of my content, 3D printing videos, music videos, and STEM videos, please consider subscribing. My latest music release is the Universal Serial Bus. It's a cool new video with hand-drawn background animations in a meditative style. If you like that kind of thing, please check it out. I hope you enjoyed this video and have a great Saturday!